Good evening, my name is Andy Schiefelbein. You may remember me from such talks as Java-enabled Python, Jython. Yes, that was a thing. And Perl, you could, but please don't. So what we're going to talk about tonight is a little bit in the realm of cryptography and configurations. And pardon me, I'm having some really bad allergies this last week with the pollen, so I'm going to probably cough a little bit. But the thing that we're really trying to do is prevent other people from getting our data. Really, that's down at the end of it. So you have Ciphers, you have transport layer security, and you have stuff on disk, you have stuff going through the network. So we're going to try to cover a little bit of all of that tonight. So if you have any questions, feel free to shout them out. It's very informal. This is just based on the stuff that I've done and stuff that I jokingly know how to do. One of the big things, if you haven't seen the Khan Academy on what is cryptography, and it takes you through everything. This is a fantastic course. If you haven't gotten this one, it's going to go way more in depth in cryptography and all of the mechanics behind it. Really great to watch. I think I've watched it 3 or 4 times. The other thing is something I've often referenced is Ken Thompson's essay on trusting trust. There's a link out here on the our Go meetup repository, the St. Louis Grow with STL Go repository. There's under the docs there's a cryptography markdown. But the Ken Thompson, I believe, is also one of the lead developers of Go. If it's the same Ken Thompson, I'm pretty sure it is. But his treatise on trusting trust is really interesting. It's how do you verify that it's trusted? And somebody was saying, well, you just trust the compiler earlier. Well, he explains, well, what if you didn't audit that compiler and somebody put in a little exit that would write something out and then send it over the network to you? How do you audit that, and how do you make sure that the things that you trust actually trust? And then the other thing is the XKCD cartoon, if you see it here, which is, you know, saying your laptop is encrypted with 4096-bit RSA, we'll never get it. And then the next frame is hit them with this wrench and drug them with this $5 whatever it is, and then they get the answer that way. So no matter what we do, the biggest problem we're going to have is we as the individuals are generally going to leak the information. So that's the preamble. Is everybody familiar with Wireshark? Or is anybody familiar with Wireshark? So in your words, can you tell me what Wireshark is?
It captures network packets and you can inspect them.
Correct. For those on the web, it's a way to capture network packets and inspect them. So what we're going to look at right now is, I'm just going to go to the loopback address because I have 2 services running on my laptop right now. We're going to look at a pure HTTP only. So the transport layer is just straight, clear HTTP. We're going to do a sign-in, and then we're going to look at what our packet inspector says. So if we go over here with localhost 8080, so this is a non-encrypted straight HTTP sign-in. I got to pull the password. Give me a second here. So, you know, it's super secure. I got the password right here. But let's just say, for example, this was sitting on a span or a tap port in your ISP. You have no idea who's sitting there looking at your span or your tap ports, or if somebody has it on a router and you're sitting in a coffee bar and you're doing this. So if we go admin login, we just logged in. So if we go back over to Wireshark here, and we're going to look specifically for the WebSocket protocol, because this is working over WebSocket. We have our hello, which is sending the initial setup. And then if we go, we just see our ID and password right here, clean text, plain as day, using an off-the-shelf software to inspect our TCP packets. This is how it's super easy to do this. And because if you have to look at the number of links between you and the next person, each one of those routers or switches has a span or a tap port that you can sit there and look at all of the packets. So whenever you're sending stuff clear text, and nobody should be sending stuff clear text anymore. That was gone 20 years ago. But when you do, this is what happens. So that's what I'm getting towards is sort of the why we're doing this, not necessarily the how. We'll get to the how eventually, but it's important to remember these are the reasons why we have to do these things. It's not because we can't be secure. It's that we must be secure because there are people out there that can take advantage. And I have a personal anecdote about this at the end. So we're going to go back here. We're going to actually continue without saving. I'm going to start listening on localhost again, but I'm going to go to the secured version, HTTPS, and I also need to pull that password, so give me 1 second, please. Once again, super secret, of course. And we'll log in here. All right, we logged in. If we go back to Wireshark, we see, in place of what was the WebSockets, you see the TLS 1.3s. And the most you get is a hello, you get a source and a destination. So you can still infer some information from that, but you can't decode it unless you have the private key. And I didn't take the time to set that up tonight to show that you can actually do a man-in-the-middle attack on this. If we want to do real in-depth SSL discussions at some point, we can come back to that. But tonight, this is more of a survey of encryption and encryption schemes. So, but if that's something y'all want to talk about, I'd be happy to talk about that. It's one of my 3 favorite subjects. The other 2 being trombone and the 3rd one being gardening. So if you look at this data, it's all just garbage. You should not be able to decrypt any of it without a private key. So the other part of that, so that's transport, that's data in transport over the wire. So we have data movement, and then we have data at rest. If we look at data at rest, in this case, I have the HTTP only, this guy here is an HTTP only service. I also have a database sitting under this, just a SQLite, unencrypted SQLite. The one in the main version is encrypted, but for the demo tonight, I set it so it's unencrypted. So if we take a look at that, you can see this. Clear text, plain as day, all of the data is right there. You didn't even need to do anything other than just look at the file on the file system, and you got data. And this is, again, how stuff gets leaked. Because if somebody gets on the system and you can just view this, okay, well, you got a problem. With the main program over here, that, sorry again, with the cryptography enabled, if we take a look at the same file, the grow with, it's gonna, well, let's do it command line. Do it apples to apples. It's garbage. You can't get it because it's encrypted. And the only way to get it unencrypted is to have the key to get in there. And that is the goal of this, is to make sure that people can't get to your data that you don't want getting to your data. So does that make sense, more or less? We're going to talk a little bit about ciphers and hashing and, yeah, I think those 2. And a little bit about configurations in a bit. But is anybody familiar with what a Caesar cipher is? In your words, what's a Caesar cipher? Very good. Yes, it's also called a shift cipher, where you take, for those on the web, I'm repeating here, it's where you take your the position that you're at in the alphabet and you shift it a certain number, and so instead of it being clear text, it's enciphered at that point, so that a person who wouldn't know what the correct shift is would not be able to decode it. This is they call it the Caesar cipher because it goes all the way back to the Romans, and this is how they communicated battle plans. And eventually, and we'll see here in a bit why, this is not particularly secure. So I have a little sample program out here called the Caesar cipher. And, well, let's just run it first, and then we'll talk about what this does. So, does anybody have a good phrase? Like, you know, quick brown fox jumped over a lazy dog, something like that?
I eat my own dog food.
Okay, well, give me 1 second. And if I can spell, there we go. We're going to do a basic input. What kind of shift do you want on that? The default on this program is 4. It's in between 2 and 25. What number would you like on that? 7 it is. All right. Oops. No, what? It's a dash shift. I don't know why I didn't do a dash. Probably because it's an input. Oopsies. All right, let's try that again. So what you have here is the plain text, or the plain text input, I eat my own dog food. You have the ciphertext, which does not look correct on this one. Do I have my... Odd. Well, we'll try this anyway. But what we'll do is we'll take this and we'll brute force decode it, and then we'll walk through what the program does. All right, let's see if that, okay, we'll do that again with the brute force thing. So this one, for whatever reason, did not do that. Let's try that with lowercase I. I wonder if I did something incorrect on this, or... Yep, that's all right. It's the uppercase I. So I got to look at that program, because it should have made it a lowercase or something on that, but well. But if we do that, oh, come on now. If we do this again and then put it back through the decoding, so we have our input. Oh, come on, there we go. All right. Sometimes Ubuntu and I disagree. Right now is one of those times. All right. And then we're going to try to brute force this back. I ate my own... Weird. Did I have a... I do have a capital K there on that one. That's why that's... All right, let's try that, okay. All right, now, like I was saying, once you do that, you should be able to do that. So if you take a look at this ciphertext, do you notice anything in particular that would allow you to attack that as a program?
White space.
Very good. And what does the white space delimit?
Word boundaries.
Correct. And so if you were writing a program, how would you attack this on words, essentially?
I would come up with a list of the most common words about length, and I would see, assuming this maps to this in a simple cipher, because I'm going to assume this person doesn't know technology or encryption, because that's the scenario where I'm most likely to crack this, in the scenario where this is least likely to have some kind of self-destruct button in case someone fails to crack it too many times. Assuming these match, how does that cipher apply to the other words, and if so, is that a valid sentence? Very good.
Repeating for those on the web, you attack the individual words and you look at them at the length. So what we have here is essentially that exact program that you described here. We have common words of a specific length, and what I have is a map of string struct. And why I did that instead of doing an array of words is because you do the big the big O lookup on that. It's quicker to look it up in a hash map than it is in an array. So I'm sort of cheating here because there's nothing of value on the other side of the key on these. But we have 1-letter words, 2-letter words, 3-letter words, and 4-letter words. So once we get all the input from the user, we go through and we can brute force on each one of those where we look at the input of a specific size and attempt to reverse that out and see if that reversal matches one of the common words. It's also something called the rainbow table. I've heard it called the rainbow table. I'm 80% confident that's what they call it, where you have common words and you just brute force attack it. Now, you can apply this to different ciphers. DES is one of them. SHA-1. They're weak ciphers. So the Caesar cipher is a stand-in for all of the other weak ciphers, because you can see how easily this is to break. But when you go to the other ones, you start doing something called a frequency analysis, where you can break down how many of the more common letters or characters are in there, and then you can start to reconstruct the plain text from the ciphertext at that point. So is that, we happy with Caesar cipher? Any questions on that? Comments, insults? Okay. So the other thing that we really want to talk about is we have password hashing and we have a reversible cipher. So I call it sometimes a one-way cipher, which is password hashing, and a reversible cipher, which would be if you needed to store off a database password and you wanted to retrieve it back, but you want to encode it on disk so somebody can't see it. And if you take a look at the JSON in this, here we have the SQLite specifically has an encryption key. So this one has that encrypted database that I showed earlier that you can't just view because it has the encryption key. The encryption key is a reversible hash because I need to know what that key is to decrypt the database. This user has a hashed password. So even though it's encrypted in here and it's encrypted in memory, when you access it, it will unobfuscate the thing and it will do a hash compare between what the user is inputting and what this is. And a hash in this case is just and I'll demonstrate this in a second, is a hash of the password and it has to equal the hash of the input. So the random things aren't an actual password. It's not what you input, it's how it's cryptographically compared as a hash so that they are equal. And in order to prevent stuff like the OpenSSL heartbleed thing, I'm leaving this encrypted in memory. And if you're not familiar with what OpenSSL heartbleed is, it's fantastic. Also very scary, but fantastic. It's a buffer overflow that was an attack on OpenSSL. Yes, sir?
Wasn't it a buffer overread?
Something like that, yes. Where the client could go, give me this thing that I need access to, and give me this other stuff that I shouldn't have access to, and I would go, here you go. So if your passwords are in memory, clear text, and something like that happens, there's your passwords. You know, somebody just got access to your database, and oh, I don't know, hacks your Azure account and just releases 70 million accounts into the dark web. Not that I know anything about that recently or anything. I should also say I'm not here as a representative of the company I work for. I'm here as an enthusiast of Golang. If you apply that OpenSSL heartbleed attack to cloud, what is cloud? Cloud is somebody else's computer. Cloud isn't some nebulous thing up there. It's shared memory, it's shared CPU, it's shared disk. If you can do that, and you happen to land on the right tenant, and you just hopped over that wall. I know AIX used to do LPARs, and there was a physical partition in there, but I'm pretty sure with commodity hardware, if it's shared, you're in. Anyway, that's a little bit more theoretical than actual. I can't prove that one, but something that sticks in the back of my head. So let's take a little look about hashing and this other fun stuff here.
I do have a question.
Yes, sir.
You've got the encryption key because I've got the source of your program, then would I have a way of reading your database?
If you, yes, and that's actually a flaw of this particular system, is that this secret here is the secret to decrypt this. So you would have to somehow obfuscate that or put it into like a OpenSSL encrypted file on your disk that you reference when you start up. And this is, again, not necessarily production worthy, but you know, but you are 100% correct. If you understand what you're looking at and you see this plain text in memory and you got it and you can get the rest of it, you have the keys to the kingdom at that point. So let's see, we were going to do hashing, weren't we? All right. We'll take a look at the test here. We have, what is this, passphrase? Yeah, so this is plain text to ciphertext, and this is the reversible hash, I believe. So what you're going to notice when you run this is that, well, it gives me output. All right, do we have, I'm sorry, let me debug that and see if we get the actual output from that. Come on now. There we go. All right. So you see that what do we have here? What do? We do the whole program? We did do the whole program. All right. We have a passphrase that's going to this, and this is coming back out from a passphrase, and then we have a hash compare at the bottom of this. But what I wanted to do was run this guy a couple of times, see if I can run him again and actually get the output. Because you'll see this starts with a K8 and ends with a capital AT equal sign. Let's run it again, and it should be a different text. Even though the input is the same thing, you'll say different ciphertext. Input is the same thing, different ciphertext. So the point of this is the little stupid little program I have here doing this. If we take a look at it, and this is the password. Nope, where are we? We're probably in encrypt, right? It's using essentially two nonces. And a nonce in this case is a one-time use thing. In that way, you encrypt it, you add a nonce to it, you encrypt it again. It's always going to be different. And again, the reason why you do that is because of frequency analysis. If every time you hit this, you got the same ciphertext from the same input, then you can guess the input. It may not be easy, but you can guess it. But this is the equivalent of a reversible hash, where you can take this with the secret key that you're not supposed to see in the configuration file and get the actual password back out. If we take a look now at password hashing, so in this case we're going to hash a password, which is some user provided password, and it's going to create a password hash. So, but that's going to be the same hash every time. So if we do it again, it's going to be the same hash, because you have to do a comparison of those. And again, if you leave this plain text, you can attack that. And that's why in the old Unix systems they had, they actually had your hashed password in the root password file, and eventually they got to where they obfuscated them. And so it's the same thing with this, where you have to do a hash compare. And if we take a look at a hash compare, we have a plain text input, we have the original, and we just do the bcrypt, which is a Golang library. We do a compare hash and password. So we take the original, we compare it to the one that was input. In this case, it will hash it, do a string comparison. If it matches, great. If it does not match, you're not using it whatsoever. Now, most of us are going to use some sort of a single sign-on at work when we're doing this. Most of us aren't going to be in the password business. But if you happen to be in the password business, this is probably a better way to do it. Because most of us will use SAML or Active Directory or OpenID or some variation there. And most of us aren't in the password business. I have to be on occasion, and when I am, this is what I've been doing. Questions on passwords and hashing? And okay. The other thing that I want to talk a little bit about is SSL, and that got back to our original thing of plain HTTP versus HTTPS. And this program will create a key pair for you. Technically, you could use it to create two key pairs, one being the certificate authority, and the other one being signed by that certificate authority, and you could distribute the first one as a certificate authority. But because this is not something you really want to do, you don't want to become the certificate authority, because then you have to have a revocation list and all this other stuff. It can be done, probably shouldn't be done, because they're technically self-signed certs at that point. Still works. It's a way to do development over HTTPS without having to get an SSL key pair, which where I work right now is incredibly difficult. And instead of giving me access to the system, I have to go, please, mother, may I have a certificate? And they go, I don't think we like you today. And then I have to do this anyway. But with SSL, there's a couple of things you have to do in order to create an SSL certificate. You have to create a key pair. And generally you want your key pair to be pretty big size. 4096 bytes is roughly the recommended size right now. It used to be 2048 and 1024 before that. I think 4096 is probably the safe bet at the moment. And it's probably going to go up at some point because people talk things about like quantum computing can break that and whatever. I don't think we're going to see quantum computing in my career, possibly my lifetime. I might be wrong, but I'm not worried about it presently. But once you create...
Certificates cost money, so that's probably why your company doesn't want you to
That is,
buy a ton of them.
that is true. And in the old days, we used to have an internal CA that we would just go create a request from, and they would just give it to us. And like I said, anymore, I just create my own CA and deal with the problems when they show up, which is often, unfortunately, anymore. So you create a key pair, and then you create a certificate signing request, a CSR. And in this case, we have a CSR with subject alternative names. So the common name is localhost because that's what I'm primarily hitting, but we have a couple of ones that we have grow with STL Go, localdev.org, and so on and so forth. Now, if you all want to keep hearing me babble on about doing hosting and stuff like with this is planned for later, where we can talk about vhosting within Go, and then on top of that, possibly doing some sort of load balancer type of thing with a local demonstration with HA proxy, because I don't want to pay for Akamai, and then we can start talking about clustered computing at some point on that one. So this, again, is just a certificate signing request, which is often a common name. Anymore, they want you to have your subject alternative names, an organization, a country, a state, a city, and sometimes a zip code.
The other issue you have is any external CA is not going to give you a certificate for local hosts.
That is also correct.
You have to have.
Yeah. In that case, I would probably just spoof the DNS in Etsy hosts, and that's what I'm going to do when we get to this point where we're doing vhosting inside of Go, where I'm just spoofing it in Etsy hosts. And if you're not familiar with spoofing, since we'll get slightly off topic here, but so we have Etsy hosts, which is just a basic thing. So let's edit this real quick. Actually, first let's do a lookup. So we'll ping grow with STL Go API local dev, and this should return nothing. Whoops, oh, that was interesting. Again, sometimes Ubuntu is my friend, sometimes it isn't. Yep, today it's not. Let's try this again. Copy, thank you. Paste, thank you. All right, so hammer service not found. So let's VI Etsy host, and this is the same thing on Windows, by the way. I'm not hip on Mac, so I don't know how it's done in Mac, but in Windows it's C Windows driver system32 Etsy. There's a host file. You can do the exact same thing there. We're going to add another one for 127. And see if we can do that. All right. And come on, right quit. There we go. And we should be able to do a ping now and get a response, because that's called DNS spoofing. If you're not familiar, that's how you do it. And with vhosting, you're looking up stuff on a DNS alias which is not the A name. DNS alias is usually on top of this. So it'll be a system name that's pointing to an IP address, and then that alias is either pointing to that system name or pointing to that IP address. So if you're curious how to do that, that is a way. Let's see. Anyway, so after you create your certificate signing request, you hand it over to your certificate authority, which will sign it and create your certificate. So we get the CR, we generate our public key, our private key, and then we have to sign this somewhere. Where are we signing that at? We got to sign this somewhere. Sign somewhere. Probably our public key that is generating. So generating public key, it's taking the private key, and it's generating the CSR, which is calling the template here. I probably copy-pasted some of this. So the CSR comes over, and in combination with the private key, it is signed by this guy, and it creates your certificate. So in this case, we could, instead of using the private key that we're signing this with, we could sign it with our fake CA private key to become a legitimate SSL certificate, because then you could pass out the certificate authority's public key. So that, again, is a awfully too long version of me talking about SSL for some reason. Questions on that? Okay, I think I'm actually getting kind of at the end of the stuff that I wanted to talk about. There's other things that we can talk about if you want, but I think, you know, a good 40 minutes of listening to me babble on is plenty. What I'd like to share is my own personal story with data security. So I was rattling around in an old truck for a long time, and it unfortunately came to an end when I couldn't get it fixed reliably anymore. And so I went and bought a new vehicle. And because this was 2022, I had a pandemic era build, which had pandemic era build quality issues. One of them being the fuel injectors went out. So I took my truck to the dealer to get the fuel injectors replaced, because, you know, that should be an easy thing. It sat there for 9 weeks, but waiting for parts. So in that time, I had to get a rental vehicle from them. And to do that, if you haven't done that from a dealership lately, you give them your ID, you give them your credit card. The clerk behind the counter took a front and back copy of both my ID and my credit card on the same piece of paper and stuck it on their desk. Any guess what happened next? The very next day, somebody tried to charge $1,500 on my card for something from Wayfair. I get an email alert anytime anything happens on any of my accounts because I'm paranoid. So I immediately reported it as stolen and got it all squashed, and eventually reported the dealership to the Better Business Bureau, which did absolutely nothing, but I at least did something about it. So it doesn't matter necessarily if we do all of this stuff with the 4096 encryption keys and all the password hashing you want. You got me by a simple photocopy that somebody just whipped out their phone and went bip and had all of my information right there. So data security is very important, but at the end of the day, we can only control what we can control. So that's, yes, sir.
What did they spend $15,000 on?
Houseware, couches, Wayfair. So it was, I think it was 1,500. It wasn't 15,000. If I said 15,000, I was off. So by a zero, order of magnitude. But so, questions, comments? Okay. Next topic that the next time I'm up here, which may not be next time, I was thinking about vHosting and eventually clustered computing. Is there any other topic that you might want to see in the space that I might be able to talk about? Can't guarantee I could talk about it, but there are some stuff, especially around hosting, I can talk about.
So if you're writing in C, you got things you got to worry about, like buffer overflows and things like that. In Go, are there good practices, bad practices, things that can get you in trouble? You know, even with languages that have good memory managers, with Java you can call a routine and get it stuck in memory, I know, so that it never gets freed. You know, are there things that you can do in Go the same way, or is Go, you know, I know that I always get Go's going to update because there are security improvements to the standard library. Those come almost every week or, you know, twice a week or whatever. But so are there practices that are good practices in Go and practices that are less secure in Go? And does somebody have a list of those?
I don't know. I always think you can write really bad things in any language. So, it's it's like board game or the games. The best. The only way to win the game is not to play at all.
Yeah.
But yeah, no, I don't know of any like gotchas really offhand that
You-
I could think of that
you-
it's
you-
like, oh yeah, that's a don't do it.
You can allocate a slice at a specific size and go over the end of that and panic your program. So there are things like that.
I'll have to look that up. Maybe that would be a good talk to do. Okay, so.
What you can do kind of scary, and also, as Lawrence was saying earlier, with the like Arabic languages, if you're using like Seago or something, of course, that's
Yeah.
Yeah, Go is one of those things where it's like, yeah, try not to use it unless you absolutely have to. Yeah.
So is anybody familiar with Bruce Schneier? He's a cryptography expert. I get his newsletter every month. Very interesting reading. So he worked to develop the Blowfish cipher, if you know about that. And he writes a lot of books, gives a lot of talks all over the world. You'll see him on TV every once in a while because, he'll be doing one of these, here's our expert person. So if anybody's interested in getting invited to his newsletter or interested in reading something like that, I can maybe forward you one. And
I would be very interested.
subscribe to it.
Yeah.
I've been reading him. He doesn't always do everything that's related to computers and cryptography because he had, security theater was one of his big things. And a lot of things that people do in security is the theater to make it look like it's more secure, but they don't really add to the security of the system. And so he had a couple of years in a row, he had a contest for somebody to come up with the best security theater, and then he would publish the results. He has another thing going that, I don't know if he's directly involved in it or if he was just marketing it, but it has to do with coming up with better alternatives, fairer alternatives for democracy, ways to roll security or roll computers into democracy or different systems that may be more equitable than democracy. So it's real interesting reading if you're interested in it.
That brings up one more thing that I forgot to mention earlier. I also bought a General Motors vehicle. So if you don't know, they're selling all of my data to third-party providers without my consent. And this is the type of crap we need to stop as an industry, and as a country.
And we did get a question come in from online.
Mm-hmm.
Brian was asking, what's your experience with asking AI Code Assist to review code for vulnerabilities? Well,
that's actually a very interesting question. I don't use it a lot because I use a linter. I've not found OpenAI in its various forms right now particularly useful. I don't have access to Copilot, so that might be better. But I actually use these linters, like there's Golang CI, and there's a whole bunch of them in the project out here that goes through, and it will actually tell you if you're like using TLS 1.0 or something like that, that you're using the wrong cipher suite. And it will actually pick up on stuff like that. Like, I think when I started this, I had an older version of bcrypt or a reference to a bcrypt, and it said, don't do it that way on the pre-commit hook, because it flagged me to fix it, essentially. So I'm sure AI is great on that, and I'm sure somebody will get it right eventually. I don't think it's right today. Doesn't mean it's not going to be right tomorrow. But the linters I'm using right now handle most of that for me.
The other day I was trying to ask like an LLM how do you go to like, read a file and marshal it into JSON.
Oh.
Into a structure, like JSON file, actually.
Sure.
And like, I tried to ask, and it at first it was giving me like, I think it was telling me to use like IOUtils.py file, which is deprecated, and I had like, that's deprecated, what's the other one? You know?
Yeah.
Just to settle it out.
So again, not company affiliated. So this is an observation of me as an employee of a company that I'm not naming. They did an AI training a couple of weeks ago, and me being the guy that I am, they would show something and I would go, was that generated by AI? No, it's just a website. Okay. They would show the next thing and I would go, was that generated by AI? And they're like, no. And so what they got down to was showing what looked a lot like Visual Basic from the 90s, where you're dragging and dropping controls and writing stuff on top of the controls to ask a question to ChatGPT. And I just laughed out loud at that because it was Microsoft specific in this little box, and it was never going to do anything interesting. And they're betting a lot of money on this. Anyway, but if you still were you just playing with ChatGPT, or do you need to know how to do that? Because I can show you how to do that.
I was trying to see if it would.
I got you.
Okay, well, eventually, just with a lot of pumping and correcting, so.
That actually was also something I forgot to talk about earlier on the cryptography thing. So this configs program actually will walk through your JSON. So I store my configurations as JSON, as you saw earlier. And when you put something in there that has a specific key that it wants enciphered, so keys to encrypt, so it's, password, assword, all those things. And it will take those and it will encrypt those. So if I inject one into this, am I still running this guy? I believe I am. Let me close him out. So if I inject something into this, where is you? Okay, there you are. Let's say I'm gonna make password here, and this shouldn't see this. All right, and okay. So if I rerun this guy, this should encrypt on startup, and it disappeared. Where did it go? Did it just wipe it out of there? It wiped it out of there because it didn't match anything in the struct. So, but I can demonstrate that a different way. However, if we take a look at this one here, which is an existing structure, which is valid. Come on now, there we go. All right, let's try that again. We'll go ahead and run it, and this will become obfuscated automatically. So that's a little trick that I've been doing with Java, Python. I even have a TypeScript version of this, where my configuration should be obfuscated by default. And if it'll occasionally check the file to see if somebody manually updated it, but generally on startup, I have to inject stuff. And I inject stuff with a shell script using JQ most of the time to inject specific passwords, like the company's database passwords is kept in an encrypted file, so it has to look it up out of that encrypted file and inject it into this, and then you can start it up. So anyway, that is also out there on the GitHub. It's a stupid thing. It's just a recursive walk through the JSON structure, and it's looking for keys that you want to encrypt. So might be useful to some people, might not be. Anyway. But thank you for reminding me. Wow, I talked for another 10 minutes there. Oh, yes, sir.
Do you use Go at work, or are you just a really big Go for?
I do use Go at work. It was introduced to me in 2019. It was 1.14 at that point. And I found it to be a truly modern language as comparison to the other stuff I was programming in. I was big Java at that time. I'm like, everything is Java. And then you go to Go and you go, wow, this is actually cleaner and easier and faster. I want to do that now. So my philosophy has always been, show me the better way, and I will do the better way. This, I believe, is the better way.
By the way, I believe Ken Thompson is the same Ken Thompson who wrote C, then wrote Unix. back in the day.
Yeah.
So I don't know how much developing he does yet, but he's
Yeah.
been in the business longer than me.
And probably him and David Korn have beers on the weekend. All right, questions, comments, things you want to discuss? Okay, well, Paul, I guess turn it back over to you.
All right. Well, awesome. Thank you.